we're going to use from chapter 18, lecture 18, we're going to use question number 10. So that lays out this reaction. 2 hydrochloric acid into H2 plus Cl2. Now it also gives us the equilibrium constant for the concentration. So Kc is equal to 3.2 times 10 to the power of negative 34 at 25 degrees Celsius. So question 1 asks us to write the equilibrium expression, or part A, asks us to write the equilibrium expression Kc for the reaction. So the equilibrium expression is always the products over the reactants. And whatever coefficients we have, specifically for the 2 hydrochloric acid, the 2, it goes to that power, so the power of 2 on the bottom. So then part B asks to find the concentrations of each gas when the system reaches equilibrium. So how we do that is we fill out this ice table, and we realize that the initial is given to us for hydrochloric acid, that being 0.375 moles. For the other two, we're going to say those are 0 because there's none in the system to begin with. So 2 moles of the hydrochloric acid turn into 0 moles, so it's minus 2x. We add 1 mole of H2 and 1 mole of Cl2. So we have plus x and plus x. Now for E, the equilibrium, we take I and C and we add them together. So 0.375 plus a negative 2x is 0.375 minus x. Additionally, 0 plus x is x, 0 plus x is x. Now we take these equilibrium and we put them into this equation right here. So that turns into this. 3.2 times 10 to the power of 34 is equal to, so this is Kc. Apologize for the background noise. This is Kc. Now this is what the equation is, right? So we had H2 plus Cl2. So those are both x. X times x is x squared. And then at the bottom we have right here 2 hydrochloric acid to the power of 2. Now since we know that x is going to be, since we know this is so insanely small, this bottom number, denominator of x is kind of irrelevant. So what we're going to do is just have 0.375 to the power of 2, so x squared over 0.375 to the power of 2 is equal to this. Now we can kind of just simplify this and divide and do a square root to a point where the square root of 0.375 squared times 3.2 times 10 to the power of negative 4 is equal to x, which is 6.7 times 10 to the power of negative 18. So then the final part is what is the equilibrium constant Kp for the reaction. Now this is the conversion equation for Kp, where R is equal to 0.0821 liters atmospheric per mole times Kelvin, and T is the temperature of the reaction in Kelvin, and then little triangle boy N is the moles of the gaseous products minus the moles of the gaseous reactants. So let's do N first, because this will make the whole thing easier, because there's 2 moles of products, 1, 2, and there's 2 moles of reactant, 2 HCl. So 2 minus 2 is 0. So RT is to the power of 0, which means all of this is equal to 1. So Kc times 1 is equal to Kp. So Kp in the end is 3.2 times 10 to the negative 34.